So here we want to match the equation with its type of graph here. So just a reminder, if we multiply by something, so in this first one right here, if we multiply by a trig function, then we're altering the amplitude. So that one right there is altering the amplitude. So we have an amplitude change there. And this one right here, again, is an amplitude change here. So this amplitude would be exponential. So normally, right, sine and cosine, they oscillate bounded by a straight line at the top and bottom, right? Like y equals 1, y equals -1. Here we're saying oscillate with a exponential function determining your amplitude instead of a linear function. So exponential functions look kind of like that. We'll have the positive and the negative version of that exponential. And then we're going to have a wave that oscillates in between there. And it's just going to keep getting bigger and bigger. So kind of like a oscillating in a cone kind of thing. And I would say C looks most like that. That looks like an exponential function coming down there like that in the negative direction or a decreasing direction. So I think this one right here is C. And this one right here would be oscillating with not a horizontal linear function, but a straight line linear function. So kind of like that. And so then we could have a wave that oscillates inside of that on either side. So which one looks most like that? I would say D looks like a straight line coming down there and through there. So this one right here must be D. When we add or subtract here, that relates to our midline. So here, instead of having a constant midline, like y equals k, we're going to have an exponential midline. So again, imagine an exponential function rising up, and then we wave around that as the midline. And which most looks like that? A most looks like that. And so that means this one should be B, but let's think about that just for a second. So we're adding something on, so that's my new midline. So then imagine a straight line, kind of like one of those rabbit problems we did. And we're oscillating about that straight line. And that's what it looks like we have right here. Oops, not a very good straight line, slightly better. So this one right here must be B for mine. Other thing you could do is you could just plug in some numbers and see what happens. Pick a number for A and B and compare it. So let's just do one of those for fun on Desmos. And this one was kind of like that spring problem we did earlier. So the period is just very different. Let's just give it a smaller period or a bigger period. Let's make that a 5, maybe 10. And then my exponential, let's just have it drop a tiny bit quicker, like 0.6. So here I can see that it's dropping down exponentially there. So if I just graph the exponential separate, y equals 15 times 0.6 raised to the x, I can see that the exponential is forcing those peaks down because I'm multiplying it. That's my new amplitude. And then if I just do the opposite of that down here, that would be the bottom bounding curve. And oops, I forgot to put the negative in front. So it's oscillating in between there. That's beautiful. If we change that to an addition, then it would try to follow the top curve. So if I get rid of this here and make this an addition, so I change this to the midline instead of the amplitude, then it tries to oscillate with that curve as its midline there.